Hello guys, I'm Alokosha Enoch. Welcome to another tutorial section on probability and statistics. In today's section, I'll be taking a look at IGCSE exam style questions on tree diagrams. Okay guys, let's get started with probability. Okay, so tree diagram, so that's the exam style questions, okay, and let's take a look at the first question guys. James goes to an arcade. He has one goal on Teddy Grapper. He has one goal on the penny drop. So the probability that he win on Teddy Grapper is 0.2, and the probability that he wins on the penny drop is 0.3. So we have to complete the tree diagram for the question above, guys. So this question A. Okay, let me just activate my live shot and complete the question accordingly. Sorry about that, guys. Okay, so we have to complete the probability tree diagram. Guys, don't forget that the sum of given probability always equal. Let me say certain event is one, so the sum of probability is always one also. So for a certain event, probability is one, and for certain is zero. Then you can have even chance etc. Okay, so now if probability of win is 0.2, definitely probability lose will be 0.8. So that when you sum the two, then it should give 1. Okay, so that one is cool. Then here, probability win is 0.3, and based on the same explanation, this will be lose will be 1 minus 0.3, that's 0.7. Okay, let me just put this. If probability of an event is E, okay, then probability not that event will be 1 minus probability of the event. Okay, so probability not, we can use prime for that. Probability E prime. Okay, so something like that. Okay, then yeah, now okay, the problem I'm going to have here is win lose, I don't even know the proportion, whether it's evil chance or whether it's certain event, whether it's likely, unlikely, very likely. Okay, so guys, let me quickly show you something. Okay, so now here I'm going to have probability win win. Here probability win lose, probability lose win, and probability lose lose. So I want to call your attention to something. And another thing is that I may need to, because I'm using light short, I will not be able to track my previous solution. So probably I may need to put some information down. Okay, I think I should be smart to know what I'm doing. Okay, so now, yeah, now probability. Just to complete this. I don't need this way win yet. Probably I'm going to need it. A big part of the question. So now, but this is where I'm going to probability win lose here. So probability win lose, and here will give me probability lose win. Okay, let me just show you what I'm doing. Okay, so if you take this and this, you have win win, probability win win there. Then this with this, that is win lose. Then lose win, then lose lose here, probability lose lose. Now if you are observing, now this is win win, sorry about that. Now if you, this is if it's a commutative, because when you product when you multiply two number, or you add two number, is commutative, because 2 times 3, for example, let's say this is 2 and this is 3, so 2 times 3 we give you the same thing as 3 times 2. Is that clear? Okay, so if that is the case, then the probability win lose and lose win should give us the same answer. That's what I just want to confirm to you. So now, but here I already have probability win lose, because probability win here is 0.2 and probability lose here is 0.7. So win lose here will be 0.2 times 0.7, and that should give me the same answer, even though I don't have the value here. Okay, I don't have the value here. I don't know what I'm going to multiply with 2.8. So let me just call it probability of win, PW. Okay, that's what I'm looking for now. So probability of W now will now, then since I know probability win lose is the same thing as lose win, so this place also will be 0.2 times 0.7. But in that case, guys, I need to use my calculator, and just to, I don't want to be too smart, guys. I'm not going in multiplication of numbers. Okay, so let's go take a look. 0.2 times 0.7. So that gives me I don't want to work in fraction. That gives me 0.14. Okay, so here is 0.14. Now from here, now I can now finish up. Then I have probability lose 0.8 times probability win. That's what I'm looking for. Should give me 0.14. So from there I can get my probability win. So that will just be divided by 0.8. So 0.14 divided by 0.8. So that should give me the answer there. So and that is 0.175. So I'm going to complete this one here. Let me put it in rectangular box here. So the answer here, the answer, let me just put it up there. The answer here should be 0.175. 0.175. So I'm through there. Is that clear? Okay, now also similarly I need probability lose here. Okay, I need probability lose here. Now in this case what I'm going to do now is I cannot say, you can't say for certain because okay, no, I can do this one. But I was trying, I want to do something more. Oh, since I have probability win here and this is lose, so I'll just have 1 minus 0.175. But I don't want to write that there, so let me just get the answer. Okay, so I'll just take away 1 because I have probability lose here. So based on this one now, probability not win means probability lose, so that will be 1 minus probability lose. So that will be 1 minus 0.175. So guys, just use your calculator to do that. 1 minus 0.175, and that gives me 0.825. So the answer here will be 0.825. So that if you sum probability win and lose, then that should give you 1. So I'm good, guys. The only thing is that I don't know if I need to put some information down. I know that probability win lose and probability lose win is 0.14. Then probability lose is I don't know that, should I multiply? Okay, if I want to get that now, because I don't want to come back, I don't know what question they're going to ask me in the B part. Okay, if I look at this, what kind of probability that James win on the Teddy grabber and he also wins on the penny drop? Okay, so that would be a win-win. So let me just do that. Probability win-win will be 0.2 times 0.3. So I have this down, guys. Just put it in your mind. I'm going to use the answer later. So probability win-win is 0.2 times 0.3. That is 0.2 times 0.3. So 0.2 times 0.3, and that is 0.06. Okay, so guys, this is video you can rewind and finish up. Okay, so let me just complete everything. Win-win is 0.06. Win-lose, and then lose will be 0.8 times 0.825. 0.8 times 0.825, in case I need the information later. Okay, they didn't ask me for those though. Okay, so that is 0.66. Okay guys, that was cool one. I'm going to exit now, go to the next question. So it's video, guys, just take your time. So next question says that what kind of probability James win on Teddy grabber and also wins on penny drop? So let me go back to the tree diagram. So because here, if you look at this question here, I should have taken the two together though. If you look at this question here, I have win on Teddy grabber here, and then win on penny drop. So that is probability win-win, and I got that before. That will just be 0.2 times 0.3. So 0.2 times 0.3, and that would be 0.06. Guys, hope that is clear. Next question. We have a lot of questions, guys. So let me just take my time. This time around, I think I will try to solve A and B together, because so that I don't lose track. I'll make it a little bit smaller. I'm sorry about that. Okay. Okay, let me just read the question first. Natalie has 8 socks in a drawer, and 5 of the socks are black and 3 of the socks are white. Natalie takes out its socks at random, write down its color and put it back. Okay. Write down its color and put it back into the drawer. So this one is replacement. Okay, event with the probability of an event and with replacement. So we can have without replacement. Then Nathaniel takes out the second socks at random, write down its color and return, because we yes, okay, that after write down the color, then put it back and return. Okay, so probability of the only thing is that let me just get this now. I know that the total outcome is 8. Total outcome is 8. Black is 5 and white is 3. So I can work with this now. I can go down back to the diagram because I have all the information needed already. So let me put it down for you guys to see. um total outcome, I will represent that one with T. So total outcome is 5 plus 3, which is 8. That is all the socks together. Then sorry, okay, sorry about that. So that's total outcome is 8. Probability white, not probability white, number of whites, sorry, number of whites is 3. That's white socks. And number of black socks is 5. Then number of socks altogether, that is total, is 8. I don't know why I'm putting it in. I just like this. See, is this something like that equals to, don't mind me. Okay, so now let's get started. Now we have to complete the probability tree diagram. Now first, so black. So probability black is sorry, number of black is 5 and total outcome is 8. So probability of an event is possible outcome divided by total outcome. So possible outcome divided by total outcome. So that is 5 out of 8. That's probability for black here. Then also white, that is 3 out of 8. Possible outcome for white is 3. Then out of 8 total. Okay, now don't forget that this is the first trial. Let me change it. Let me change the color now. So for the first experiment, okay, that will be the second trials here now. But the only thing about the probability, the only thing about this event is that it's with replacement. Okay, because Natalie actually replaced the socks, but such that the total outcome will remain constant throughout the event. So total outcome remains the same throughout the event, but probably, but the number of socks varies. Okay, so now second, now since this is black first time, so black second time, black will reduce by 1 because black altogether is 5. So you've taken 1 out of the black here, so it's remaining what, 4 blacks. Oh, sorry about that. It's not remaining, it should be remaining 4, but since it's replacing it back, I'm sorry about that. Okay, it's replacing it to return the black. So if you want to take black second time, consider that black is still 5 because it's returned. Wow, why is this like this? It's with replacement. What? This seems not to make sense to me, but it's actually correct. Okay, so now because it's with replacement, so the socks is returned, so it's returned 5 back, so it's still the same thing. So white too. So this is not funny, guys. I'm expecting something to happen, but that is not the case. So I think without replacement will just make sense. So throughout the stuff, I think the game will be the same. As this one, he has taken white before, the white should have reduced by, but it's not good because it's returned. So it's game over for all. So it's constant throughout. That is not funny. So white will now be 2 over 5. 2 over 8 rather. Yeah, and if you sum the probability here is 1. If you sum probability here is 1. If you sum probability there is 1. And if you go ahead and do black, black, white, white, that thing will be the same. So let's check. What kind of probability? 2 socks are the same color, yes. So 2 socks are the same color will be white, white, or better say black, black. Let me take it here. White, white, black, black. So same color will be black, black. So probability black, black will be 5 over 8 times 5 over 8. or it could be the same color, could be white white. So all means plus, then probability white white, that is 3/8 times 3/8. So at the end here we're going to have 25/64 plus 3 times 3 is 9/64. So if you sum 25 and 9, so 25 plus 9, that is 34. So 34/60. What am I writing, guys? Say 34 and I'm writing 36. Sorry about that. 34/64. If you don't mind, you can reduce it to lowest term, and that is good. Okay. So divided by 64. So just that's 17/32. And if you don't mind, you can leave it like that too. No problem about that. But it's better for you guys to reduce to lowest term. So that's 17/32. 17 out of that's what my yes 7 out of. Okay. Okay, so that's the answer, guys. This video you can rewind and check, guys. Next question. So now this question says that, let me see the B part. Okay, please, I would like to take the A and the B part. And in that case, let me just let me look at the information I have here. A football team has 2 matches to play. The probability that the team wins is 0.6. The probability that the team draw is 0.3. Okay, so in that case, let me just have my the two probability down so that I'll be able to use that. So probability win is 0.6 and probability draw is 0.3. So from there I can take it up. So let me go down to the tree diagram now and the B part of it. Can I make it smaller? I need to. No, I don't need to. I think I will just manage the ball like that, guys. Okay, so because if I use my light shot, I will not be able to navigate up again. So that's why I just need to see what I need to do. Okay, guys, we have to complete the tree diagram here also. And don't forget that the sum of probability of an event should be equal to 1. So now we have 3 possible outcome here. Win, draw, or better still, lose. Now, and the sum of the 3 probability should be equal to 1. So 0.6 plus 0.3 is 0.9. So therefore probability lose will be 0.1. So that is equal 1. Okay, let's just continue the section. Okay, so now we have to complete the tree diagram and work out the probability that the team win both matches. So now if probability win is 0.6 and probability draw is 0.3, then probability lose will be 0.1 because the probability sum should be equal to 1. So similarly here also probability win is 0.6, so just fill it in like that. And probability draw is 0.3 and probability lose also 0.1. So that when you sum this here, it gets 1. Then you start the iteration again, 0.6, 0.3, 0.1. So that the sum here also will be 1. Then finally 0.6 for win, 0.3 for draw, and 0.1 for lose. So the only thing is that when you now sum probability win win and win draw, win lose, draw win, draw draw, draw lose, lose win, lose draw, and lose lose, the sum of the probability here also should be equal to 1. Okay, don't forget that. So what can the probability that the team win both matches? So win both matches will be probability win win, and this is only where we have win win. Okay, so our probability win win will now be what? 0.6 times 0.6. So you can go ahead and use your calculator to complete that. What is 0.6 times 0.6? So that is 0.36. You can confirm that. 0.6 times 0.6, that's 0.36, and that's the answer. That's all we are asked to do, guys. There's still a lot of questions there. They have asked us for more questions, than I would have done accordingly. But the only thing is that if you sum the probability here, it should give you 1. So let's continue. Okay, yeah, now so that I don't lose track, yeah, so let me just take A and B together. Okay, this says Jennifer is playing that, and she throws two darts aiming for a bushey. Okay, so the probability Jennifer hits the bushey on first row is 1/4, and the probability she hits the bushey on second row is 1/3. So complete the tree diagram. So here, if probability is 1/4, definitely probability means will be 3/4. Just do 1 minus 1/4. Okay, so here now, probability it here is 1/3. So by default, so I say by default. Okay. So conventionally, probability means will also be 2/3 because that will be 1 minus 1/3. 1 minus 1/3. So now to find the probability it here, there could be a little work for me to do here before I can get to this one too accordingly. So what I'm going to do is just like question 1. So here I'm going to have probability it miss. So that is HM. Whoa, HM. Yeah, it's like headmaster. Okay. And this one is probability miss it. So what is like miss it as in miss it? Yeah, it's miss it. I can't miss anything, guy. What do you mean miss it? Yeah. Okay, so miss it. MH. So probability it miss and HM and MH should be equal. Now, so let me just go for probability HM because I can find that already. So probability HM will just be a probability that's 1/4 times 2/3. So let me confirm that, sir. So 1/4 times 2/3. Guys, I'm lazy. I'm supposed to do this. This multiplication is just easy. Don't mind me, guy. Okay, so now that's not a bad deal. So that's 1/6. So 1/4 times 2/3, 2 here 1, 2 here, so that's 1/6. Okay, so this here is 1/6. So definitely probability here 2 miss MH will also be 1/6. And I'm looking for probability miss. So when you multiply 3/4 times probability miss, probability M here, then that should give me 1/6. So by implication, probability miss will now be 1/6 divided by 1/6 divided by 3/4. So and that means 1/6 times 4/3. So I'll just use that one. You can use your calculator, guys. So 1 divided by 6, or 1 divided by, your calculator can do it directly. You can go ahead and use cross multiply and you still get your answer. That is 2/9. So here is 2/9. 2/9. Or you can confirm that again. So that will give. Then finally, I don't need to waste my time again because definitely probability miss it here. Miss it here. Okay, I will still need I'll need this one here. So 1/4 times 3/4. So that is 1/12. So if I sum all this probability now, 1/12, 1/6, and 1/, then I'll take it away from 1 to get probability miss here. So let me just do 1 minus then the probability there. Let me put that in. Let me just confirm that so that the sum here should be 1. 7/12 plus 1/6 plus 1/6 then plus 1/12. I'm misbehaving already. Plus 1/6 plus 1/12. So that should give me 1. Correct. Okay, so I can now go ahead and finish up here now. So probability miss here now. So probability miss here times this probability here should give me 7/12. Therefore, probability miss will now be 7/12 divided by, so here will be 7/12 divided by 3/4 means times 4/3. I'll stop using calculator now, guys. Year 1, year 3. So the answer here should be 7/9. So what kind of probability that Jennifer eats the shell at least once? So eat at least once is going to take this one and then eat it, and this one also. Okay, so in that case, I can also do the same thing as 1 minus miss. So that will give me the same answer. So the answer is going to be like the sum all this one here. Okay, which same thing as 1 minus 7 out of 12. So that will give me this 1 minus 1 minus 7 out of 12, and that is 5/12. And because definitely this will give me 2 plus 2 plus 1, 5/12. So the answer here is 5/12. This video, guys, you can rewind and enjoy the show. Okay, I'm getting tired already. Yay! So let's take a look at this question. This one says that in a small village, one bus arrived a day and probability of rain in the village is 0.3, and if it rains, probability of a bus being late is 0.4. If it does not rain, probability of bus is 0.1. So complete the stuff there. So now this one will be 0.7. We don't need to waste time again. I wasted a lot of time trying to explain, so you know that when you sum this will give you 1, so I don't need to waste much time again. So this place will be 0.6, and this place will be 1 minus 0.15. So 1 minus 0.15, so that's 0.85. Now work out the number of days the bus will be late over an average of 80 days. So be late. So now we have late here, and we have late here, because the question says that what are the number of days that the bus will be late over, so whether it rains or not, late anyway. So late rain and no rain late, that's what you're going to consider. So and so this one here will be 0.7 times 0.15, or plus rain late 0.3 times 0.4. So when you sum these two together, one bus arrive a day. This is per day. So the answer here will be per day. Then for 80 days, that will be times 80. So let's go ahead and do this first. So now this will be 0.12. This one here will be 0.12. So 0.12 plus what is this one here? 0.7 times 0.0.15. 0.15 times 0.7. So that is 0.105. So 0.105 plus 0.2. So that gives 0.305. So 0.305. So 0.305 is per day, because they say that arrives a day. So for 80 days, that will just be times 80. 80 days will be times 80. So 40 year 1, 40 year 2. So the answer here will be 18 days. Guys, this video, just go ahead and confirm. And for some reason, slowing me down. What? Okay, so let me just be fast and time. I need to upload this. Let me see if I can solve the last question here without wasting much time again. Okay, so this is a good one without replacement question. Okay, let's use this one as, because all the questions are similar, so I just jumped the remaining one. It's just going to be like the same, guys. So George has a bag of marble. There are 6 red and 4 white marbles. So George takes out a marble at random and record its color without replacement. Okay, so George takes out another marble at random, complete the probability tree. So this one is without replacement question. Okay, so let's take a look at how we're going to complete this task. Okay, so here now I have a probability red will be 6. Possible outcome over that total outcome 6 plus 4, that is 10. Our probability white, possible outcome here is 4. Then total outcome is 10. 4 plus 6, 10. Now the only thing about this question, or like question 2, was that this is, I don't know whether it's question 2 or 3 like that. This is without replacement. Okay, now if I have to have red the second time, because I pick red first time here, so a number of red will drop by 1, so that will be 5. And total also drop by 1, so that's 9. Okay, now red first time, white second time. So this first time I'll be taking white, so white still remain 4, but the total drop by 1 already because I pick red first time, so this will be 9. Here also white first time, red second time. So red, this first time red will be coming up because I have white first time, so red is still 6, but since I've taken white before, then total drop by 1, so that is 9. And finally white first time, white second time. So white first time, so white drop by 1, that will be 3. The total also drop by 1, that is 9. So this question I said I find probably that the two marble are the same color. So same color means white and then red. So white, red first. Okay, let's go for red. So 6 out of 9 times 5 out of 9, then or white, that is plus 4 out of 9 multiplied by 3 out of 9. So I promise you not to use calculator again. So 6 times 5 is 30, so that is 30 out of 9 plus what am I doing? I don't know. I say why 6 out of 9? This is 6 out of 10. This is 6 out of 9. Oh my god. Okay, sorry. So red 6 out of 10 times 5 out of 9. Okay, sorry about that. Then 4 out of 10. Wow, today is not funny, right? Times 3 out of 9. Okay, so 6 times 5. 6 times 5 is 30. 30 over what? 90 there. Plus 12 out of 90 here too. So that would be 42 out of 90. So that's probability same color. If you like, you can convert it to decimal. Okay guys, and that's the end of our tutorial for today guys. I hope you enjoy probability 3. And what I'm going to do now guys is that because of our time, there are some questions, 1 or 2, that I didn't really bother to solve. They are just like the same day too. Okay, so now guys, what I want you to do, what I'm going to do now, let me just show you something now. Guys, I'm going to upload the worksheet on my test shop. Not this is my site also. You can go ahead and get a lot of stuff there. Just Google Alikosha Enoch Weeks, okay, my blog. Okay, so leave that one there. So now I'm going to upload the board work for probability and statistics on my test shop, so you can download freely guys, and you can also access a lot of mathematics ICT and coding video and board work here too. So not just the video, so and the board works and resources, okay, e-learning resources, and so you can avail yourself guys. Then also go ahead and to my YouTube, you can go ahead and download the video now, and also make sure you subscribe to my channel guys. Please subscribe to my channel guys.
Wake the streets up. Okay. Wake the streets up. Okay. Come on. Okay. Wake the streets up. Yeah.